point that you often see is this kind of let's see, if I go reply and then I go pop out, I can bring it over here. Right, so basically what we're looking at here, and so Harasu, jump in if I say anything incorrect, or if, and it'd be neat if you could also update us on kind of where we're going with this. But basically what we've got is we have I got sent this, which had these pretty graphs, and it has a data set which is in an Excel spreadsheet, and when you look at the Excel spreadsheet, we've got x1 and y1, and x2 and y2, and x3 and y3, which are the difference, right? So they're x1 or x2 minus x1 and y2 minus y1, right? To just get the differences between the two values, not as absolute values, but just as a subtraction. And so what we've got here is that it's believed that the attack, and so we don't actually need to worry what that is there. So the change in the system has little or no effect on the data. Here I want to show similarities between position y1, so with position x1 y1 versus one with position x2 y2. And so he shows a graph of saying, oh look, you've got this is a heat map graph, and then this is a heat map graph. They're similar, and so that's a kind of, well, this is a distribution of these points along the line. We don't know if it's changed much. We don't know how different those are. These two graphs, you look at them and say, well, they're similar, but one of the challenges with saying, look, they're honestly similar, is that it could be that you have rotated the order, which means that the results of doing the second operation versus the first operation is incredibly different for an individual, but not for the distribution as a whole. So unfortunately, this just showing that it's got a similar distribution of data doesn't mean that each data's position is similar. It just says, yeah, these two end up with averaging the population in a certain way, right? So, if I gave you a score on height and that ranked people and it gave a distribution in height, I could get a kind of relatively uniform distribution with a large chunk in the middle and lower at either end. But I could also then measure you on your preference for chocolate ice cream or something, right? And I might get another distribution that might look similar to height, but each individual might be very radically different position. So just looking at a distribution like this doesn't tell you that these two operations are similar. It just says they generate similar distributions. Now that distribution could be something about the underlying information, and so that when you actually look at it, you go, okay, well these are similar, and they might be completely different. So so these two aren't good at showing that, and Harshu identified that. So he did, well, what about doing a heat map of the difference? And the heat map of the difference shows you this. And again, that's 4 pixels. It looks like there's 4 pixels and a couple other pixels, and it's kind of, I don't really know. Is 100 a massive difference, or is it a tiny difference? The problem with showing a graph like this is that although you might want to say, look, the differences aren't large, without understanding why we have a scale up to 300, I could show this as just a scale of 0 to 10, and that would look like there was a massive difference if I zoomed in right in this wee pixel over here and say, look, massive change, everything's changing. And it's kind of, well, scale matters. And then I have to understand why I've scaled it to this size. What is the purpose of scaling it this size? Why are we looking at it so far away? So all of these questions come into how we present this data. Now, if we use a different heat map approach, you get these more blurred out distributions. Now, this is the same distributions as these two, just done with a Gaussian distribution heat map to spread things out rather than put them in such a tight line. This isn't really useful because it's actually obscuring the data to some extent, and so this would be, I would consider a prettier but worse, right? So it's prettier than those, but it lies about some of the size of the data, right? Because it's spreading to make things visible rather than representing the data as itself. And assuming that, the data might actually be noisy, then the spread is reasonable. But when the data is potentially less noisy, then yes, you don't have the same reason. So, what we're trying to achieve is we're trying to say, look, these two things are relatively similar. How do we show that in graphs? And how do we get a better representation of this data than these, which are okay, but not great, right? And this one isn't very informative because we've zoomed in too close. And these ones just tell me about the general distribution, nothing about the operation of X1 and X2 and what they actually do. So here we do the normal and the epsilon version. And I see that we've had a few more people join us. Excellent. Now, if you guys have any questions, certainly type them in the chatting area. Okay. My hard drive got excited. So type them in the chatting area so that I can see any questions you have, or if you don't understand what we're trying to achieve, kind of get clarification here. So for the more, he did a scatter plot to try and find the relationships, and again you see these are the two scatter plots, and again we don't know if these are actually similar or if they just have similar distributions. So he's played with the data with histograms and 2 points to try and work it out. Okay, so the question is, what other possible ways can I plot these? So my audience, that the points in X1 and Y2 are similar and show that the difference is not significant. From the plot, X1, Y1 provides the audience from the different research areas, so such as all the rest of you guys. Yes, I want to pass the message by making them try to understand from the graphs. Okay, so there are a couple of ways that you will start to approach this. Okay, so the first thing I did was, now you didn't share any actual kind of R code with me, Harishu. I don't know how you generated these graphs. So were these generated in R or in Tableau or another program? Python. Aha, right. So you're using Python to generate these graphs, right, which is perfectly reasonable. Okay, so what I did is I took these and I said, okay, well I'll play with these a bit myself. One of the things that I was trying to look at is if you do these kind of graphs, you're saying that these are the distributions, the points you came out, and these are the other distributions, the other points that came out. What you are interested in is actually kind of where they moved to. And so, yes, you're right, it's this difference that's important, but we're trying to show that the difference isn't large. And so we need some way of showing the scale of those differences, okay? And not just showing them directly, but also saying, well, okay, what is the how do those differences relate to the size of the vector, for example, or other kinds of noise signals that we might expect? Because there can be some things where you say, if I have viral load of 1 part per million, then that's 1 part per million. That's tiny, so obviously I have no virus. But that may be enough to kill me, right? So just because a number is small doesn't mean it's not significant. You have to work out what it should be in relation to, right? So small variations can be very meaningful, or they might not be. So here you need to have that baseline. You need to convince your readers of something like saying, well, this is a scale of up to 300, right? So these numbers vary between negative 100 and positive 400, and so a variation that mostly sits in near zero suggests that the differences between these are smaller than the range that I'm getting, right? So I'm trying to say, look, any point here, you'll find its associated point quite closely, right? So that's what we're trying to show. Basically, we're pairing these two graphs together and showing how units move between them. So in one way, we've got so much data here that it's obscuring what we want to be able to say, and that's basically what is the maximum distance that an individual point travels, right? So if you looked at a point here and you drew the graph over top of each other, a bit like you're doing here, but you're not connecting the points. You're not saying which point is connected to which other point. And so that's why this graph fails, is because I can't see which red and green. Now, I just happen to know that this green and this red, so if we go really close, can I get in? Yep, okay. So if we look closely at this graph you generated, this green and this red are a pair, and this green and this red are a pair, and this green and this red are a pair. So those are pairs, and they have nearly zero change. But just overlaying them like this doesn't tell me that that's what's going on. And so we actually, rather than having the individual points here, what you'd want, what if we permute y2 so if you were doing a permutation of y2 and so y2 and x2, permuting those would say, well, if I moved them, and you can see there are more pairs up here. These two are paired. Permuting them would say, yes, if I permuted a little bit, you'd see them wiggle, and you'd see them all come off each other, which is adding randomness to your data, so you don't necessarily want to do that. What you could do is you could have lines that were from x1 to x2, and so you draw all of those small lines on here. Rather than drawing these as circles, you draw them as small lines, and what you'd see is a massive number of tiny wee lines and only a few long lines, right? So that would be one way of saying, the data, these are where this is the distance away from these two data. Now, that is actually why it's the y x3 and y3 are is basically that vector. They are a vector, and so what we've got is we've then got at the center, we then draw all of those vectors around it, basically, and that gives us a plot of that scale. Now, and that's what this graph here is trying to show, is what is the size of those vectors between all of these points, right? So these two small points here and these two small points here. Okay, so I load this up in R, and I've uploaded it into the GitLab, so you guys can go and have a look and download Attack and have a look at my R code. I'm not sure if it will run perfectly. I haven't given it to other people to test it, so this was just done kind of last night after I did all my other stuff. So what we did is I went and I had a look at the various ways you could look at this data. Okay, so what you do is one of the first things you do is, and it's kind of here, I loaded up the features. I call them features. Just give them a name. I loaded up those features as an XML. You can do that by importing dataset, or you can use the code, read Excel, and then you can view it. And these are the feature set here, right? So I've got y1, y2, and this is actually just x1 minus x2. As you can see, this 0 is the difference between those two. I don't know if you guys can see that. I don't know if the screen is large enough for you to see that, but hopefully it is. And hopefully that's recording at a good enough rate for that to happen. Okay. So what we've got here is the data in this top corner. I can't really zoom in. And what I did is, for this plot, this is a 2D plot. This is the raw. This is a raw plot of all of those points, just plotted, right? So plotted with the AES plot, and that is, I think, P1, and that's done in a heat map. Okay, so this was a raw plot to just plot all the points, right? So this is this P1 plot here. Which is what it's doing is it's just setting a green color. So it takes the features, it passes it to a grouping, so it makes x1 and x2, and it doesn't give them a surface or anything. It just plots them, and it sets the points to being size 2 and the color, and then it just does that ggplot, right? So I'm using a ggplot out of R, and it gives me this, and it's kind of, well, yes, that, as we say, that's not a useful graph, because all it's showing me is that there's a whole bunch of data here, right? So it shows me the extent that it goes from, there is the 0 point here, there's some amount of data. Again, that's relatively useless. And so the next plot you look at is saying, well, actually, we need to do a density plot, and it's going to use a raster density plot. So here I was recreating that second graph from the email. And so where did that email go? There it goes. So I'm recreating this plot here using R, and that generated this plot. Now my bins, you can see that the bins here is he's only got 4 pixels, whereas I've got about maybe 8 pixels to do the same thing. So I'm getting a similar graph, and you can change that by changing your fill size, right? So here I'm using these and the density raster and taking off contours, but it's so you can actually change the amount of sampling you do to change how close this is and how small these bins are. This gives you that similar thing, but again, it doesn't really tell us that much. It just says, there are small differences. They're mostly around 0. We don't get a really good sense of how close to 0 they are or what this data looks like. So that's where we might need, and if I really wanted to dig into this data and show it in a more kind of informative way than this, what I thought, well, okay, what I would do is I would look at 3D plots. And so we go to the viewer. So this is using Plotly. I then do a 3D surface plot by grabbing the features. And I use the mass library to generate to take the X3 and Y3 and group them in a 50. So that's how I group them together. And then I make a plot with X and Y being the KD values, X and Y, and I add a surface, right? So this gives me this graph, which then shows me the data, like how tall that spike actually is compared to the values that are low. I can also, what's nice with this is, I can inspect things and I can actually zoom around and see what they are, which is kind of nice. So it gives me a kind of fully interactive plot, which is quite nice. I can actually then export this to an HTML page. So you can actually have this code in HTML. If I go to export here, I can save as web page, and that will generate a web page. And if I overload test and go save, yes. Okay, so that will create a web page that I could upload to somewhere and actually have online that does this interactive. I'm able to interact with the data, which is kind of a very nice way of showing it off. Also, this three-dimensional data, this for me is a much clearer that we have a really tall spike, right? Now looking down from the top, you can kind of see what we had with the small spike in the center. But this shows you that 0 is really, really actually tall, and as most of the data is there, very little of the data is around. Okay, so if you wanted to show how sharp this was, doing a 3D plot of that data might be the best way to show how sharp it is. Interestingly, it's not the differences aren't perfectly symmetric, and you can actually see that by looking around in this graph a bit. You can see that it's a bit knife-shaped. It's wider on the x-axis than it is on the y-axis. and to some extent you could show, if you were putting this in as a picture in a journal article, you could show the 3D plot like that and a 3D plot like that to actually emphasize that knife shape. If you felt the knife shape was interesting, if you felt that the variation here was more interesting than the variation here. Now, of course, the other way to do that would be just to do a distribution plot like this, right? It would be to actually kind of, rather than make it a full 3D plot, is you just do a histogram of the amount of data sitting in each one of those. So what I did is I also, because I was exploring data, I also went to this and I said, well, okay, if I have my original XML spreadsheet, what happens when I make a scatter plot of, this is actually the Y1 and this is actually your Y1. It's X1, Y1, this is X2, Y2. I don't know why that's not showing it, but that shows X2, Y2, and that's X3, Y3, right? So you can see this is that clump of data. These range to 500, this ranges to 150, so you know that there's something similar. You can see there's some odd data going on out here, and there's some odd data going out here. So you can see there do seem to be some outliers lying away from the center line. But this, again, doesn't really tell you very much. It just says, you know, that's where the data is. I don't know how much is in the center here. I don't know how much is in the center here. You can see these are this is slightly wider than that. I don't know how big that is. I then had a look at the charts and saying, well, okay, if you just did a distribution of Y3 and just did a distribution of X3, you get these kind of charts showing you the size of the bins. So this is 0 to 2. These are the bins, and how much of the data fits in those bins. So you can see here that it's not a normal distribution. It's quite a tight distribution with some falling away and, you know, some wide outliers. Are you sure? No, I didn't want to exit. I was just trying to shift over here. Right, so is that all making sense so far? You kind of understanding where we're at? Okay. I'm not getting any responses. I have no idea whether you guys are actually listening to me at all. Oh, someone's typing. Yes. Okay, that's all good. Nice to get at least a teeny bit of feedback. One of the nice things about being on Twitch is Twitch people generally like talk a lot, so they chat in your window a lot. Okay, so this becomes like one of those. So Excel generates these. This is not going to be useful. Kind of thing. So what I want to do is I want to say, yes, this is the useful plot, but again, this plot is just a mess, right? And so it doesn't help. This third plot along the top here doesn't really help me tell any story. And so what we want to do is we want to tell a story. What might be good to do, and one of the things you can do in these situations is say, well, all of this data is great, but maybe I need to pare back and just show some parts of the data to make it easier to read, right? So rather than showing all of the columns, I only want to show, 100 picked at random, right? So that's the idea, is that you might need to actually, although you've got all the data, and you certainly want to show all of the data at some point, and use kind of this style of R graph to show all your data, right? And certainly for me, if you're going to put your article online and you're going to share your data online, having an HTML page which allows you to do this and look around this data is just nice, right? That's a nice, cool, interactive thing that R will give you. And this was me having a look at this for a couple of hours last night, right? So it is relatively powerful. I also felt that although this is quite interesting. It shows just a big spike in the center, and I think this might be a better way of talking about how distributed it is towards the center, rather than just the yellow, because the coloration doesn't really show me as much as that shows me. I don't think, right? So what do you guys think? Do you think you get more data out of the 3D plot there, or out of the 2D plot here? Usually I don't advise 3D plots, by the way, but I think this amount of data is probably useful. So right, Harisha, you're happy with the 3D data, so I will go thumbs up on that. Let's see, where's my thumb up? Where's my thumb up? Got to get to the, there it is. I should really just type thumb. Yeah, so I'm thumbs up on 3D. So the 3D plot you can see is quite useful. Now, just to show you how you edit this. So if I take this 3D plot, at the moment I'm doing this view is showing me Y3 and Y2. If I go X1 and Y1, this will then show me that plot of the long data. So now what we're going to look at is basically one of these, right? We're going to look at that one, but done as a 3D plot. So if we do that, and there's a couple of ways you can do this in R. I can actually just run that individual line, and it should run that individual line. And it should, oh, no, I'm on the wrong line. So I need to be in this line and go run. And hopefully, oh, okay. So I needed to, oh, you know, I did put them in and then plot it. Okay, so why am I getting, so x1.html, okay. So sometimes that one is a bit finicky. So sometimes the viewer in R, for some reason it doesn't refresh properly, it doesn't update properly. So you kind of have to go, given the viewer didn't update and I can't see anything here, I don't know what's going on. So no, let's see. Yeah, so you see it's kind of, it's lost its will to draw things. So at that point you have to save to Webpage, and then you can get to see it as a Webpage. Now, so this is the 3D plot of X1, Y1, right? Now you can see that there are some outlying data over here, which is what some of that outlying data when it wandered away from that center line that you saw there. You can see these two bits these bits of wandering away from the center line are the bits here that's where it's one. You can see there's tiny wee bumps here saying that there's only a tiny amount of data. But this gives you an idea of how that data looks. Now, at the moment, you are presenting us basically with that line as the, well, actually like that, as that two-dimensional plot that we see in the email, which is that one, right? So that one is basically like that. If you guys are willing to believe me, that those two are similar. So that can be useful, but again, it's you read this because that scale is hard to know what that color actually means. Then something like that gives you the idea that in the same visual space that I'm using for this, I could show something kind of more informative about what's going on. And you know, you could of course just do the histogram plot, which would be the side-on plot along this axis, which you could also generate, which would just be the actual total numbers. It does kind of hide these ones, which is these outliers, because they are not just straight on that side. So this gives you this idea that actually that is a relatively thin kind of line with most of the data occurring in this point. Okay, so that for me. If you wanted to show off this line, I would say, well, that's what that looks like, and you could show this graph. You pick a nice angle, you do a print, you download at a particular angle, and although you might need to work out scales because 70 mu is kind of awfully small, so you have to do some changing. But you know, this was me. I did this in an hour and a half, 2 hours last night. I was playing with your data, so you can do this relatively quickly and get out good data. So this is a nice visualization of that. Of course, I can then also generate the same visualization by putting in, and of course what I would do is I'd say, okay, let's copy and paste that, and we'll paste it down here, and we'll actually call this KD2. KD2, and I would do, then you could do 2 and 2, so you're not overriding your data, and then this would be the 2 and 2, and then plot and add surface, and then save, and I'd click on this one, and that would, I can run that individual line, which will generate. Now, just so you can actually see what's going on here, KD is also all of the things I've been playing with, and there's some random variables in here because I was playing with random surfaces. But these are the KD1, and you can see all the data points there, and this is KD2, and you can see all the data points there, right? So so you can see what data it's generated, and then I can go here and I can go run. Now, the reason why I'm not just because I could just type these down here. The reason I'm not, and it woke up that time, the reason I'm not doing that is because I want to save what I'm doing. Now, I can save, the terminal will save, the console will save, but it's nice to have it saved in a file so that you can go back to it and talk about it, and you can include that code in your thesis by including the R code so people can see what you've done to generate the graph, right? It's very, very useful to put this sort of stuff in an appendix, because then it helps people understand how you generated your graphics, and then they can, when they get fresh data, they can generate the same graphs to compare with yours, right? Which really is quite useful. So here you can see now my viewer actually woke up on this. Let's see if I can. So this is the other data, right? So will it have woken up for that one? No, it's lost the will to draw those ones, and now it's lost the will to draw that one. Okay, so as you can see, the browser here is not great. If I export this to save as webpage, and I do x2.html, sorry, it's just, not all programs work perfectly all the time, so you sometimes have to just work around the flaws. It's currently loading that. There we go. This is now the x2 data. And you can see x2 data looks remarkably similar to x1 data. And in fact, I'm more convinced that they look similar between those two, right, if you've got them exactly the same line, than I am just the pixel values. So it's really hard to see any actual difference in these two, right? And because this tends to have a bit more information, what you do is you'd make sure that your angle was identical and that you're looking at the data from the same position, so that you actually see that these are two different sets of data. I'm pretty sure it is actually saved the right file. It's sometimes hard to know, but I suppose what we could do is, it's not responding. We can actually check by generating the third plot, right? So what I'd do is I'd regenerate that third plot here, just to make sure that I have actually, that those two graphs are actually different, because it looks, I'm not convinced that they're different graphs, but as we said, the data is so similar that it would be hard to see the difference anyway between these two. All the scales are identical. The line looks pretty identical, so I can't see a difference. Okay, so it's finally waking up there. So what you do is, so kind of for my sanity, I would create a third plot type, and let's call this KD3, and we'll get this from X3 and Y3. And I will plot this from 3 and this from 3. And, yep, did I get... Okay, that's possibly why there you go. So this was a copy and paste error that you see regularly, something that you need to pick up. I had used KD2 KD rather than KD2. in generating the height graph of that. So in fact, it probably was the identical data. So that's on the plot. So that would be a fault of mine, which you'd want to check. Okay, so that's why you kind of want to. I'll run that again. All right, so that's generated KD2 data, and here, because Z should actually be KD2 data, not KD data, and then run that line. And see if the viewer wakes up. No, the viewer did not wake up. So that was the KD2 line, yep. So it's taken a while, it's not responding. It might wake up and respond. Still not responding. Okay, it's taken a while. So those are some of my ideas around drawing those graphs. Now, in your wording, you're going to have to be very explicit about why you consider the variation small. And that probably needs to be some sort of line drawing where you use a graph where you do... it did wake up. So this hopefully is actually now the correct data. Wow, it's really struggling to keep up with me moving things. Okay. It's having problem both recording and streaming and having my OBS open. So I think I've confused it too much. But oh well, we're now looking out from underneath. That's nice. Let's see if I can just slowly drag it. So this again is the yes, you can see this is different. You see here we've got a kind of the peaks here are two slightly different peaks, and if I have a look at here, you can see that that peak is slightly lower, right? So you can see, I don't know if you guys can see on your screen, but if I zoom in and I look at the top of this section, and I need to move it down. Ooh, killed it. Okay, so we'll reload that page and see if I can get it back. So, so if I'm having a look at this one, I've got too many of these open. My machine is struggling to display them. So if we look at X1, you can see that it was like this, and when we look at X2, you can see it's got a wee kind of these are close to being symmetric. Wow, too big. Okay, so my machine is really struggling to display all of these all at the same time. I probably should stop some of the displays. Okay, so here, although you might not be able to see it, because these two peaks look similar, are now the same height compared to this one where they're different heights, I can see that this is actually slightly different data. It's also rotated. I'll rotate it to the same orientation. So we've got kind of a peak, and peak with slightly different data, and another peak here. And here you can see we've got the same sort of peaks, but they're not quite as sharp there, and they're a bit more muted here. That one's as peaky, but this one's, and these ones are a bit sharper than this bit here. So yeah, you can see that there is some data going on, but it's not perfectly identical, which suggests that they're similar but not identical, right? So that would be one way to show these two, and then showing this one with its very tight line, saying, well, that's the variation you get. Now this is a 100 scale, so this goes 100 to, and this is 150. So that's 150 and that's 100. You would want to set those scales to being the same as these, right? And now if you did set them as being the same, then you could say, well, okay, look, if you think about how far they move, this suggests that they're not moving far. They're moving kind of, most of it's only moving up to about 50, right? So if you look at here and you come down and say, well, 50 range is going to cover most of the variation. 25 is going to cover most of the variation. And so and you can see the variation is slightly different in the X than it in the Y. Y is about 10, right? So that's a kind of a very kind of coarse way of seeing those two, and you can see then show those graphs in 3D. So that's the code. That's how you'd use rplot to do those. Now, for what I did actually to do that, I went through and I was Googling the various how to do these kind of things. So I was going various. So the couple of sites that I used that were useful for me were we're going to talk about that in a minute. Because of course you find a whole bunch of challenges when you do this, but data2viz.com. So this 2D density plot was how I got the code here to regenerate this one and this one. Okay, and then it used the Plotly library to generate this 3D plot. Okay, so that was I found that page was very useful. I mean, you had to tweak the code and you have to play with it around to get to about the right size, and you can fiddle with it. But it was able to show why that's not particularly useful. This is much more useful, and this is even more useful. And I think actually for your data, this might be okay, and this is slightly better. But for your data, the spike is even clearer when you show it in the 3D. So I found that site very useful, and I'll just copy that and put that there, and I'll put it into the GitLab as a useful link, but I'll do that shortly. And that's how I found it. I googled for it because that's what we do, and I looked for Plotly 3D surface with bins, and I saw that one and went, oh yeah, that looks something like what I'm looking for. And then from finding that view, I went, okay, where does that come from? How do I get that kind of thing, right? So that's how I found those pages, as I went looking for this, and it's a bit down in the thing, but it's down here. I saw that, went, oh yeah, that's looking like what I'm wanting, and then I went through and I found those, and you can see other people showing you again similar ways of doing scatter plots of displaying that. I also had a look here at Plotly. So Plotly does a default. So the Plotly.com, which is the tool, it has a 3D surface plots in R, and so that's again a 3D surface plot, and you can see here it's the Plotly, and it uses the volcano data which comes with the Plotly library, and you can do, and it shows you how to do these sorts of things and create websites that allow you to kind of view those sorts of data. Okay, so Plotly is the other one, 3D surface plots. And Plotly, I'll just put that in there as well, so you can see the tools that I was using. So that's another place I went to have a look to try and understand and learn how these things worked, because I had not done, hand on heart, I had not done any 3D plotting in R before last night. So this was me learning last night how to do this shit, right? So it can be done. You can learn how to do it, and so yeah, I was also Stack Overflow, as you'd expect, looking at how do you deal with data frames and these sort of things, and there's lots of useful data. I didn't use this one, but I also use Stack Overflow, and you can see here it kind of gives you help on how to get R to do the things you want it to do. Right? So as you can see here, this was Plotly, and I also found this was so. Rather not that one, it's the one before that. Where is it? 3D surface plots, must be this one. Okay, these were, yeah, so this was also on how to do data science with R on coronavirus. Right, so the second thing I was going to talk about, so do you have any questions about that? Harashu, what do you think? Was that reasonable? He's just typing. That's perfect. Great. Okay. So although I didn't show you the line type graph that you could draw, if you peered back your data, so you might be able to show that overlapping and show, if I pick 10 points at random, I can see that they don't move very much, right? So potentially, rather than showing all your data, just show 10 elements and show that those ones don't, and then just pick those at random. I would say in general that might be more useful than showing all of your data, because it becomes overwhelming. But I think those histogram plots are pretty clear what's going on. So I think you can the 3D plots are pretty good. Okay, so the other thing that one of the other students had done is that Fazal had a look at Tableau, and having me pointed to the Tableau source, spent bits of Wednesday and possibly bits of Thursday playing with the Tableau dashboard to create his own COVID-19 tracker dashboard, right? And so I thought, well, hey, we'll show off what was done in a day of tinkering, which is kind of cool, and also look at discussing what's good about these and what's bad about them and how we might use these. Right, so this is daily cases, it's worldwide. This is showing you it's relatively flat. Currently, we have a date scaler, which you've added, so we can scale this back. The date scaler here is a bit far away from here, so I would potentially argue that you should have, and that this particular element should be connected more tightly with this daily graph, right? So that's just a kind of layout issue. This is useful. I think it shows you that it's choosing when to give you a number. Yeah, and that's okay. I suppose you're not in charge of that, so that's not something that you've decided whether or not to put the number in. It can be useful just because it gives you an idea of what scale there are, because we don't have a scale on either side. I would, on a more informative rather than a dashboard version, I would want to see that actually had the scale. It does allow me, because it's a dashboard and it's interactive, it does allow me to click on these things and see more information about individual dates. Now, these bars are a bit wide because you can see that they're actually overlapping each other. So this graph has actually got some issues around being able to display and see everything. So so I think there are an issue here with its width of bar is too wide, and so it's not scaled properly. Right, so that's a challenge for this particular plot. World maps are great. People love to see where they are in the world, and you can. Of course, it does the world thing where it wraps, which is always a wee bit crazy. But it means that we can click on New Zealand, and it will then select New Zealand and show us just the New Zealand numbers. And yes, unfortunately, we had a negative one. That was because this 9 was actually supposed to be 3, so that this was actually 5. Yeah, because we actually went down 6 and added 5, and so. Yes, it was this should have been 3 and this should have been 5. And yeah, that adds to 8. And so that's not evenly distributed. So that's why we had this bad piece of data in here. We got a 0 because the time at which we reported didn't line up with the recording. So you would normally consider those bad data. All right, so here we're showing you as it is, as the data came in, without doing some adjustments to correct for things. And unfortunately, you need to show, if you're going to show the data, you've got to show that data and then explain why you might have done a cleanup, right? So you might want to do the cleanup if your data is really bad and you know why it's bad and you've got a unified, reasonable way of fixing it. Then you show the raw data and you show the fixed data and explain the fix, right? But be careful not to just fix data and then present that as true, because that's not how the data came in, so it is not accurate. We are also, unfortunately in New Zealand, we are reporting numbers differently here. So we actually don't have 1,400 confirmed. That's what that's what the Johns Hopkins data is actually reporting. The WHO reports us as having 1,100 confirmed, because we are reporting, and Johns Hopkins have been adding all of our probable cases as well as our confirmed cases. So we are actually, technically this number is higher than it should be. We actually only have 1,100 confirmed, not not 1,400 confirmed. We have, because we've added probables. So understanding your data is important in explaining it. It's nice here. You've got a nice wee histogram. You've got the cumulative of cases and recovered and deaths. Nice to see. Quick wee graph created from that. I'm not sure what's going on with this line, because it's saying 38,000 and 218. That feels like it's adding us with someone else. It seems that there's another 36,000 people that's somehow been added to here. So there's something going on in this area. It may be to do with adding the province or something like that. So this is got some bad data down here. But for tinkering for a few hours, I think this is a kind of neat wee dashboard to put up. In terms of usefulness, this is probably more useful because it's a selector, so I can click on it and then get this other data, right? I don't know if I trust anything down here because it was so far out, but this gives me the Australian data, and it's up to about 6,000 and about 7,000 and about 6,000 recovered. So here we've got a 91,000, which I'm again not sure where that number comes from, and Queensland 32. Again, that's not the number that's actually represented here. So this table has some problems, but this is a good selector. These are good headline numbers, though I would expect these headline numbers, because I've selected Australia, these headline numbers change. I would expect to see the name of the country in here as well, right? So I'd expect this to say, Australia. I think I can, if I'm right. No, I can't double click those. But I can in here, and this is terrifying. If I turn off all, the map disappears and everything goes away. I can turn on, because of the way this is set up, it allows you some interesting new things you can do. So for example, I can click Norway, and now everything will come back because it will show me Norway. And it should show me the rest of the world. There we go. So it will show me Norway. But then I might say, okay, those are the numbers for Norway, but I'm actually interested in the Scandinavian region, and so I can explicitly add Norway, Sweden, Denmark. So this is now combining regions, and Finland. And so now I get to see how much are in this grouping that I've done, which is a nice interesting kind of side justification for saying, okay, if I include those, and of course Greenland and Iceland. So Greenland. Oh, it doesn't have Greenland as an option. Greenland does have. Greenland had almost no cases, so it doesn't actually really add much. And Iceland is there, bang. So that adds me this wee one up here. Okay, so this is a nice selector. It means that I can say, okay, in this region, I have 41,000 with 11,000 recovered. Okay, so that's actually a nice feature of having built this and used multiple values. You can then see how those group have changed over time. Now, actually, this is mostly driven by Sweden, and so Sweden are the ones who are trying a different way of doing this, and you can see those numbers change significantly when I take out Sweden. You get much lower numbers, right? So, and you can see it's now decreasing rather than going up. So that's a nice way of visualizing these and seeing it online. No, these aren't ones I would necessarily put in an academic journal. I think these ones, that's academic journalable, right? So you could actually put that in. I though I don't think this gives me enough information, right? I would actually, rather than that one, I would potentially prefer to see this sort of histogrammy one, right? Now, this histogram was actually done on the difference data and is basically just a side projection of it, which may or may not be useful, right? Because again, I lose data when I look side on because I don't know necessarily if these vectors are being retained in the same way. And actually, you can see here, I've tried to scale, so I've scaled this to get these two to look similar. But you can see this has got to 100 minus 118. So if I actually scale this one wide out, you can see that if I try and match, because what I should be doing is I should be matching these scales so that you can actually see if they are similar, and that's a bit closer, right? So these have got these have got wider bins, and trying to make them look the same. So this histogram is something that you might expect to see more of. But if you were ever to do this, honestly, if you ever do this, I will be extremely critical of you, because you can see what I've done here. These are exactly 2 and 0, 1. These are on a different scale, right? So what you need to do is you need to actually do on the, where is it, format axis. So I go to the format axis in here, and I have to make them the same, right? So I'd have to make these, I set the other one to overflow bin at 100 and overflow bin at negative 100, and I set bin width to being 2, and right, okay, so now I can scale this down to being the same size, and I can then actually compare the Y and the X, right? And so these chart titles, this is actually the X values. So the chart title here should be X, and I'd say variation in X1 and X2, and this would be Y. So that would be a way that you can see, and again, very similar, but you can see they're slightly different, and also the scale here is wrong. So first of all, I had to make sure they line up, right? And they do, so that's good, because when I compare, if I change an axis and try and do a compare, it's going to be wrong. This also is a problem because I've got a 2,500 and a 2,000. So to actually make that clear, I would need to make that to being the same, and actually say, well, that actually should go to 2,500 to match these two. So that should be what I would do. Right? Now again, this is allowing me to check the spread this way. If I wanted to say how high those were, then I would move it onto the side and actually check against check them side by side. This allows me to kind of visually see the spread rather than the height. If I put them side by side, I get to see the height. So again, this is telling me what kind of data what kind of story I'm trying to tell. Am I caring about the spread that way of the data, or am I caring about the height of the data? Okay, and that gets me to tell a different story. Okay. So yeah, no, so those are the two things I wanted to go over. One is that good data of like how I show potentially use a 3D plot. Not often are 3D plots good, but I think for this data it was. I would also think you could probably find a chart type that was X1, Y1 to X2, Y2, and actually show each of those little lines. And so to do that, I would do, and you might have to bear with me, a line segment plot R. So, wow, my I've got so many graphs open that my thing is going. Add line segments to plots. So this is showing me how to do that. Let's do images to see if I can find a graph that would look something like it. So this is, me. It should be line. So that it's gone with line. Okay, so here we're looking for what are the lines? I'm thinking something like this is what we're looking for, but I'm just scanning through these charts. So this is geom segment. Okay, so geom segment looks like it might be what I'm looking at, and so because if you're saying what is the vector difference between a whole bunch of individual items, that's where you might want to use. So it seems segment might be the way to do this. So I go into segment, and this is a ggplot in R, and I then looking for, okay, so I get the R code, and it requires grid. Let's see if we copy that, and we go to my R thing. And you guys don't, I mean, if you want to go off and do other things, you can, but if I put that in here, just so I can save it. Back to the beginning. Okay, so what I'm going to have to do is just quickly, I'm going to have to get rid of that plot, because I think that's using up a whole bunch of my my processor. It's having to draw all those graphs. So I require grid. So let's see if we've got, so if I paste it in here, I'll just paste it in the terminal and see what it complains, if it does complain. Okay, so loading required package grid, so it tried to load that. It then created the data, and as standard, it gives me an error in options, geom segment. So this is what you'll find is that anytime you use R, you'll probably get errors, and you then have to go and try and fix them, right? So that's where you'd start. But this geom segment is what we'd be looking for, and this is a 2D plot, so I probably should have put it in the 2D area. And I could try and update. So you see here it's got, it said D equals data frame. So it created the data because it wanted to be able to create that data. And then I have these are all the options that I have. And I'll just move that out. See if I go away from that browser and see if it gives me some more processing power. Okay, I would go in there and you see it's got this mapping. You then have to kind of go in and say, well, I copy and pasted that, but this obviously I don't want to use that data frame. Error in options title equals geom segment plot. Could not find function ops. So title, see, okay, so that line, that ops line, I think that line is just to give us that's a something I haven't loaded. There must be another package. You get this lot now, you need to load lots and lots of packages. So what I'll do is I think I just copy that out. I'll get rid of that one because I don't actually need it. And instead of okay, I can get rid of that as well. It's obviously not required. And let's just see what happens when I run that, if I get the actual data that it would suggest. And it's thinking. There we go. So it did actually draw those plots, which are a dot and an arrow. And it got the, you can see here we've got X position, Y position, and then vector VX and VY. So this has got those points. So if I wanted to say where that X1, this has got it as vectors, I then try and work out, okay, can I do it at line segments and go points? So yeah, this would be the process. I'd start looking for those graphs and start looking at how do I set this up so that instead of having arrows and blue arrows of size 2, I had just straight lines, and I want these segment points. So instead of saying D equals data, I think geom segment, I could say features. Oh, feature. Oh, I'm caps locked. So features is my data. So instead of using D, which is what I'd created here, and it created a data frame, I actually am using features, which is what I read in as a table. And then I'm going to use the segments are going to be I could use x3, right? Because you've already created a difference. Oh, sorry. X1 is the start point, and Y1 is a start point. And the endpoint is, now you've got Y3, so what I could do is actually I could just say I can just say the end is X3. Now I could have also, without actually knowing that, I could do X2 minus X1, so I wouldn't need to have that X3. And the Y end, hopefully, if I get this right, Y2 minus Y1. And I'll leave it in here just because I'm being nice. Let's make this X1 and Y1. And shape for, we'll make them smaller. That will leave them in. That will leave those points in there. Now, I haven't done this before. This is me live coding. I have no idea whether it works. Let's give it a go. Let's hit run. Okay. Something is... Okay, it's not responding. We'll just have to wait for it while it goes through. I suppose it is drawing a huge number of line segments. So it probably got too confused. Invalid plot index. Okay. So that was that one. Is it going to go one more? Next. Yes. I think I might have... Oh, wow. Whew, okay. Okay, so as you can see, that's a really, really bad graph. With lots of points. So it's obviously got it wrong. I've probably set my size is probably... my size is 23. So I tried to make my size 2, but obviously I didn't remove the 3, and so yeah, I got that really wrong. So those spots all got really big. Also, I've got far too much data, and these lines are just, aren't telling me anything. And that's why I said, how do I limit the amount of data I plot? I don't know in R. So let's go R, limiting the number of data points displayed. Okay, so this is me just riffing on how we do this sort of thing. So limiting the number of data points displayed, adjusting X and Y axes. No, what I'm doing is I want to decrease number of rows. Maybe it's limiting number of rows. Right, so I don't think that found me what I want to do. Limit the number of rows displayed in a data frame. That sounds much more like what I want to get. Oh, well, that's an issue, right? So, okay, it looks like in my data frame, I do some sort of bracketing here. So that's what I want to see if there. So there is and that wasn't particularly useful. How to limit the number of rows, Stack Overflow. That might give me a better idea because that's someone having the problem. Right, date 1:5. So, make the max dot rows equals 6, and okay, so this looks like what I do is I use a square bracket around the it to give me a scan of rows, right? So instead of using all of the data frame, right? So instead of using all the features, I just give it a range. I have no idea if this works. I've not done this before, so let's say we just do the first 20. And I'll see if that works here as well. Copy, paste. Okay, so let's see if I hit run. What did it actually run that whole segment? There are only 6 columns. Oh, so that was column selection. Okay, so that's not row selection, that's column selection. Okay, I didn't know that. So that would have limited the number of columns I use. How we can perfect the number of rows in the output table is, for example, cable head data or cable dat 1,5 comma. Okay, so maybe because I only gave it a single value, it assumed that was that. If I go comma space, it might go, oh, you mean rows rather than columns. Okay, this is me experimenting and trying to show you how I would learn to do something. I don't know if this is useful at all for you guys, but you don't have to be here. Ah, there we go. There are the first 20, though that looks like they moved around quite a bit. That's because I think, right, I might have so there are points at the start of each of those lines, and that's 20 of them. They've all shifted to somewhere else in the area. I don't know if showing the size 2, let's make that size 1. And yeah, so this might be a better way, and maybe it's X3 is a better way here, of showing whether these guys are moving and how much they're moving. So maybe I want to do 30 of them. I think the blue arrows are a bit strong, so we'll try doing 30, and then I'll run that. So this might be I mean, if you wanted to see, this actually looks like your data does move around a reasonable amount. But you can see where it's moving to, and this is one of those things that I was saying around not necessarily. Oh, I was on the wrong line. That one, and run that line. Not necessarily seeing how, given that the way that these are moving, they're all moving within the area. So it looks like all of these guys are all mapping to this location, and all of these are mapping to this location, and all of these mapping. Oh, these are mapping to zeros, things. Okay, so these are. Right. I think that might be a misrepresentation of how this works. I think maybe I need to do. I'm not sure the X one works for negative values. Yeah, no, I think there might be a problem here. What we can do is we can try putting. How about we just draw lines between rather than a kind of drawing we vector. Let's just, maybe I got that wrong. Let's just put a vector between y1 and y2 and see if that's the actual one we do. So rather than it being a relative vector, we'll just make that the end vector. And let's see what we get there. So I think I got that wrong. We'll try that. That's probably going to be a better solution. You know, again, we make mistakes. We look at it and go, that doesn't look like I want it to look. That doesn't tell me, ah. Now that starts to look reasonable. And in fact, if I make those arrows look terrible though, right? Because the arrow's arms are far too big. But I could go, oh, this makes sense. What I can do is I don't want arrow. I want now there'll be like a line or something like that I can use. If we just remove arrow entirely, I think it will draw a line. I think it will just draw a line segment if I just remove the arrow to say what arrow type it was. I might be wrong. I've never done this before, so this is me testing something. Let's see if that just draws me a line segment. Yep, those draw me line segments. And that way you can see, so an XY point and an X1. If, you know, you could just say, okay, what I want to know is I could copy and paste that and say what I actually want is I want both the X and Y plotted. So I do plus, and I want, why did that not paste? Oh, it did paste. Right, okay. So I want these, and I want circles, because these are j-own points. I want points at 2 and at 2. And I will make these red. So if I then plot that, this might be a better way of showing what you're trying to talk about, as far as I could tell from the discussion, which is how far do these points move, right? And so here we're just picking the first 30, where we assume is somewhat randomly at 30. You could actually say, you know, I pick all of these. But here you can get to see, oh, these are systematically moved, all in a way, and these haven't moved really much at all. So it might be interesting then to say, well, okay, what do those movements look like? And if I make this up to 300, I don't know if the first 300 are different to the last 300 in your data, but let's try that. Let's see if that tells a different story. So again, we're talking about how do we tell the story with our data. And so having this smaller run of data, I could then talk about, you know, if I take the first 300 samples, you know, I get to now see that I have one outlier that has done something weird, right? It's one outlier has jumped radically across the data. In this area, virtually no one's moving. They are all matched perfectly. Once I get up here, I can then see stuff is moving around, and I see a whole bunch of that movement and a whole bunch of up and down movement, right? So this is an exploration of that data that says something much more than any of those average data that I did before, because that average data was, you know, are they still averaging somewhere? But here I get to say, oh, look, there's an outlier. That's an exciting outlier. And, oh, all of these seem to be this area. Definitely you're safe. You can say that they're basically saying once you get up above 200, there seems to be something systematically has changed. So this is not kind of slowly changing. It's kind of a systematically different thing. So if I take away this and actually now go up to, is it 3,000 data points? I don't know if there are 3,000 data points. It's something like that. Oh, it tells me 23,000 data points. So I could go to 23,000, but 300 might be enough to show you this kind of interesting variation happening. And then another run. And so here, this is actually now showing me something that I don't know if I would see in the data myself if I was just looking at it and saying, yes, I understand where these things are moving. Now I get to see, oh, we've definitely got a bunch of interesting outliers. These outliers are jumping, right? They're jumping a long way, and they're causing, that we had that little bump at the bottom, we had that spray, and it's kind of, I don't know what those are. Now we can see where those points are coming from between the different data, and it seems some error measurements or some noise is happening, but it still seems very good that all of this stuff is really solid, and these, once you get above this point, there's something else going on up here. Right? Now, it's harder actually with 3,000 items plotted. It's now harder to see what's going on in this top end than if I was just plotting 300. And that's why I say, okay, look at maybe if I plot a different 2,500. Oh. So let's give it just a 500 from the middle. I'm not saying that that's a particular reason why I'm picking those 500. I'm just interested to see if the later data looks similar to the earlier data. But if I have a look at those 500, that might give me more like a clearer picture. Yeah, again, you see now when you look at this data, you see, okay, there seems to be a bunch that move white to red along, that jump up, and there's a bunch over here that seem to be jumping out. So now I could start looking at, well, which ones were those? Can I characterize those? Is there a value about those, or a feature about those, or something that's happening above this level that is causing these outliers and these movements? Okay, so that's the value of looking at your data in various ways and trying to find other ways of mapping your data, is that you might find something that you hadn't thought of before just from looking at that 23,000 representation and looking at the general average thing, that you didn't see this movement. Okay, and so that's what I think that's a useful thing of exploring your data. Now you have to work out, is that a useful story to tell? How do I tell that story? Okay. And is there something to look into that isn't just say, oh, they're mostly the same? It's now, well, these ones are mostly the same, but these ones change a bit. Okay. Well, that's 11:40. Have you guys? So hopefully that was interesting, and I don't know if any of you found that useful, but I thought it was interesting just to dig in, see how this process works, see how I would find a new way of looking at things and find a new perspective on data. Maybe, Harashu, you actually found something there that you hadn't seen before. I don't know if that's actually useful in any way to you, but you're doing a PhD, so you got some time to have a hack at the data. I will save this and I will upload all of this to the GitLab so that you can see. And you can go back through and play with the code and play and see if you could get this all to work. There is quite a bit of installing you have to do with R. I'm using R4, R version 4, and the latest RStudio. I had to update because some of this wasn't working. So you'd need to go down, and there's lots of installing packages that you have to do. And sometimes it'll say, hey, you don't have this package. So you have to install Plotly, and you have to install a whole bunch of packages. So when you get errors, just keep installing stuff until you get your R working. And then you can do this kind of exploration and then output these as you can save them as PNGs or SVGs. So yeah, you can save as image. If you're going to just put them as PDFs, you can save them PDFs, but you can also export them in like scalable vector formats or in a few other formats. So this is how you can get them out of here and then just include them in your article. Okay, great. Well, hopefully that was a useful kind of discussion on using Plotly, and I could also take you through GNU Plot. There's a lot of stuff you can do with GNU Plot. Most of that you can do with R and RStudio. I would say now better than you can with GNU Plot. GNU Plot is lovely. I love GNU Plot, but there's a bunch of this sort of stuff that is just faster and easier in R and RStudio, and that's partly why R has become the language of data science and the kind of language of kind of playing with this stuff, is because you get so much and you can do so much in a short period of time. Okay, well, you guys have a great day. I'm going to go off and have some lunch, unless there are any further questions. Do you think I should upload this video somewhere so that you can show it to other postgrads can see it? Or, I mean, is that relevant and useful? Okay, so I'll stop the recording.